We're asked to find the unique solution for the second order initial value problem. Okay, so in the book it talks about finding the general solutions. Really, you're just going to find that general solution, then you're going to use this initial value to find the exact solution. The same way you used to do this back in Calc 1. You'd find the general derivative, the integral, and then you'd use the initial conditions to find the specific. Same thing here. Now, there are a couple different versions of this in the book. So we're going to start and we write our auxiliary equation first. So I'm going to change that y double prime plus 12y equals 0 into the auxiliary equation. So the y prime becomes a squared. Then we don't have a y prime, so we don't have an r, so this is just plus 12 equals 0. So then r equals plus or minus the square root of 12i, or plus or minus 2 square roots of 3i. Now you'll notice here I'm not writing it in, but there really is a 0 here, and that's going to matter because there are 3 options in the book. There's the option if you have a repeated linear term, you have 2 real solutions, or if you have an imaginary like we do here. We have an imaginary non-real, so we're going to use that version, and that's how we get this. And it says y then is e to the alpha x c1 cosine beta x plus c2 sine beta x, where this is alpha and this is beta. Okay, so that means we have y equals e to the 0 c1 cosine 2 square roots of 3x plus c2 sine 2 square roots of 3x. Okay, then I'm going to clean this up a little bit here because that's of course 1. C1 cosine 2 square root of 3x plus C2 square root of 3x. Then I'm also going to take the derivative of this. So then this becomes 2 square roots of 3 C1 sine 2 square roots of 3x, and that's negative because the derivative of cosine is negative sine, plus 2 square roots of 3 C2 cosine 2 square roots of 3x. Okay, now we're going to use those 2 initial conditions that we had. We're told y of 0 is 1. Okay, so that means this first equation up here. Okay, this one. So this is 1, right? Yep, I have to remember long enough what I wrote. 1 C1, okay, well that's going to be cosine 0 plus C2 sine 0. Then this one here is negative 2, so this is now using this one. Negative 2 equals negative square roots of 3 C1 sine 0 plus 2 square roots of 3 C2 cosine 0. Okay, so that's 0, right? So, and this is 1. So then 1 equals C1, and this, let's see here, that's gone. I have negative 2 equals 2 square roots of 3 C2. So then 2 over 2 square roots of 3 equals C2. So let's see here, negative 1 over the square root of 3 equals C2. So then what is my equation? Well, I come back up here and I'm going to fill in. So let's see what I have. Or here actually. So I have y equals, okay, let me see here, I lost it. C1, well C1 was 1, so then this is just cosine 2 square roots of 3x. Okay, and then I have plus C2, okay, so plus negative 1 over the square root of 3. And then I have, this was I think sine, right? Yep. Sine 2 square roots of 3x. So this now is my specific answer. Now I'm going to put this into my math lab. It's going to yell at me and I'm going to tell you what it wants you to do. Because it just incredibly frustrated me. I'm like, how am I wrong? And I look at it like 7 times and I click on it, get the answer, and I compare them. And I'm like, you're full of baloney. Okay, 2 square roots of 3x plus 1 over, and it does actually seem to want you not to simplify this, which I know is just weird in itself. Radical 3x. Oh, okay. Okay, so couple things. This needs here. It actually wants here, it wants you to times these like this. And totally stupid, but if you don't put in the multiplication symbols, it seems to have a fit. It also, like, I tried radicaling it, making it all pretty. It didn't like that. So just kind of a heads up, but obviously if it marks it wrong and you have the right answer, just tell me and I'll go ahead and give you the points for it. If I can look at it and see, oh, you just didn't put in the multiplication signs. So this is all about, you have to be able to tell the 3 different types apart: repeated linear, non-real, and real, and know which general form to use. And then you're really just kind of solving the system of equations, and most of them are pretty straightforward. You can see here, once we got there, this really was knowing how to set up that auxiliary equation, and then simply getting it in the right format. So you have to do those 3 options. Got to make sure you're using the right one.